Hello, welcome to Rolls Battery Engineering Training. What we're going to talk about today is the differences between the chemistries, the AGMs, gels, flooded, calcium, or lead type batteries. Hopefully this will help you determine what batteries are best for your specific installation. Just a couple of housekeeping items. Try to keep these to 30 or 40 minutes, so appreciate your patience. Typically we'll run some Q&A at the end. Just to minimize echo, all those wonderful things, we've also muted the microphones of everybody so that we don't get any kind of weird noises or echoes during the presentation. My name is Steve Higgins. I'm the Technical Services Manager at Rolls Battery, Rolls Surrett Battery, I guess you'd call it. My phone number directly is 902-597-4020. It's my number in Halifax, or well, in Spring Hill, Nova Scotia. You can call me on my mobile, which is the 206 number. You can also send me an email. It's probably usually the best way because I'm usually traveling a couple hundred days a year. So emails tends to be a little bit easier. My email address is steve@surrett.com. Alrighty, on to the presentation. First thing I'm going to talk about a little bit is construction of the batteries. There are three primary types of batteries that Rolls manufactures, and that's a flooded lead acid, tubular gel, or an absorbed glass mat. There's some significant differences between the manufacture of those batteries. Absorbed glass mat batteries are considered a electrolyte starved battery, which means you're putting very little electrolyte into the battery to start with. Basically, when you manufacture the battery, you fill the battery with electrolyte under very high pressure. That electrolyte populates within the glass mat material, and then you dump out all the excess. This is what actually makes the batteries nice to be able to ship, because now when they ship, they don't ship as hazardous materials because they don't have a whole lot of electrolyte in them. The problem is that when you're using the battery, as those batteries get hot and as they gas or as they age, they tend to dry out a little faster than tubular gel or even a flooded lead acid battery does, because the tubular gel is, when it's manufactured, basically you fill the battery up with a gel. When a flooded lead acid battery, you can replace lost hydrogen and lost oxygen by adding distilled water as the battery ages. So that's some of the big differences between AGM gel and lead acid batteries based on construction. Now, on the product lines in general, AGM stands for absorbed glass mat batteries. AGM batteries basically are what's called a maintenance-free battery, kind of a marketing term. So be careful with that. Any battery that you put into a system or an installation that says it's maintenance free, and the manufacturer will tell you there's absolutely no maintenance required of that battery, watch out, because that's pretty much a misnomer. You always want to go back every 9 to 12 months and check your connections, retorque them or recheck them just to make sure connections are tight. A lot of times it's nice to be able to go through with an IR temperature thermometer and check the connections while you're charging. That'll give you an idea if you have any high resistive connections. Could even be battery terminals that go bad after a period of time. The other thing that's nice to do, especially on any kind of valve regulated lead acid battery, both AGMs and gels, is you load the battery, you charge the batteries up to what you believe is full charge, and then they load the batteries at about the C10 discharge rate. So you have a 1,000 amp hour battery bank, you're putting roughly about 90 to 120 amps of current load on it. And you look at the chart, look at the voltage of each cell while you are discharging, 1, 2, 3 hours down the road. A lot of times you'll be able to find out if you've got a weak cell, and if all the batteries are measuring about the same point, that kind of gives you an idea that you might have a weak battery bank and that you might need to adjust your charging parameters. Generally on AGM batteries, you're looking about 1,100 to 1,400 cycles for the AGM-S's, and they typically have about a 5-year warranty. We do manufacture a AGM-R. Basically, it's the black version of the battery, and what that battery is it's a competitor. It's typically a competitor to some of the Chinese and some of the Indian batteries that are out there in the third world markets or developing markets. Typically 12-volt models, 850 cycles. These typically have a 1 year replacement with a 1 year per it warranty. So the maximum of 2-year warranties. The AGM product line expands from all the way from 80 amp hours, all the way 80 amp hours, all the way up to 3,300 amp hours. The most common models are the R12-260. Let's see here, the R12-260, the 128, the S12-290, the S6-460, and the S2-1275. Those typically are the common models that we see on the market in general. And most of those we stock all the time. If you're going to try to order a different model, there might be a bit of a lead time. Next, we'll talk about some flooded batteries. These are the bread and butter for Rolls in general. Basically, the flooded line extends 2-volt, 4-volt, 6-volt, 8-volt, 12-volt monoblock batteries. You've got Series 4000, Series 5000, Series 4500s. The cycle lives range between 1400 all the way up to 3300 cycles at 50% depth of discharge. You can configure them from 12 volts all the way up to 48 volt plus. There's some systems, there's probably a half dozen systems around the world that are operating, a little more than half dozen, but there's a few systems around the world that are operating at 700, 800 volts DC. On these batteries, if you got a customer who takes care of them, you're going to get on an average of about 8 to 20 years of operational life. Just this last summer in 2017, I went to a site that the batteries were 16 years old, S5000 series batteries. In January 2017, I went to a site, the batteries were 4 years old and they were dying, primarily because the customer was using rainwater to top the batteries off. These batteries have a 7 to 10 year warranty. Typically the Series 4000s, are 2-year replacement with a 5-year prorate, and the Series 5000s are a 3-year replacement with a 7-year prorate. And then on next to the line, basically the capacity, we have from 85 amp hours all the way up to 4,600 amp hours of capacity. Actually 4860, I believe, 4,860 amp hours. Sorry about that. Most common models are the S480, the S550, the S605, the 6CS25, the 4KS21, the 4KS25, and then of course the tried and true 2YS31. Those are probably the most common models that most distributors will have in stock. They have some quick availability for them. Most of these batteries have been manufacturing for quite some time and different models. And then we go into the gel batteries, which we started about, the gel batteries we came up about, we started about 4.5, 5 years ago, about 4.5 years ago. These are maintenance-free, valve-regulated lead-acid batteries. They're sealed batteries. They're only available in 2-volt models. Roughly 215 amp hours all the way up to 3,200 amp hours. At 50% depth of discharge, you're getting roughly about 3,700 cycles. These are good for float or backup applications because they, while they are calcium-based batteries, they still can handle the cycle. They still have the cycle life, but they also will withstand floating applications. Capacity size, 215 amp hours all the way at 3,220. Again, the most common model numbers are the 450, the 535, the 1070, and the 2140. Those are the most common models that we sell. Good batteries. We've sold quite a bit of these over in Africa, Latin America. They're also available in racking. So what's important? It's all about the type of battery. Now, the flooded batteries are a lead antimony battery. And what that means is it's an antimony-based battery, roughly 96% lead, 4% antimony. We use a higher antimony content in our batteries because that encourages gassing. The higher the antimony content, the more gassing the battery is going to have, the less possibility of stressification on the battery. You want to, in a renewable off-grid application, you want to avoid that stressification, because what that is that the acid is settling down to the bottom, the water is floating on top, and then you get plate corrosion on the battery bank. A lead antimony battery wants to cycle. So if you have a customer who has a grid-tied installation and they go in and put a string of S550s in, that battery is basically going to sit and float. It's never going to really be loaded, because you're going to be selling power to the grid. And if the grid utility drops once every 6 months, once every year, those batteries are going to lose. What they do is they lose capacity. You can get the capacity back, but you have to cycle them, and it'll take 10, 15, 20 cycles to bring the capacity back to when they brand new. So if you do put in a lead antimony, a flooded battery from Rolls, into a backup type application, typically I'll tell the customer to, once every 45 to 60 days, you can probably go 90, but I would probably go 45 to 60 days. When you're doing your battery maintenance, shut off your AC incoming breaker. So you're disconnecting from the utility. Run your loads for 1 to 2 hours while you're doing your maintenance. Check your connections, checking your electrolyte, checking your specific gravities. And then when you're done, reconnect your loads to reconnect your AC input and let the batteries charge back up. Just doing that one simple step will keep your batteries healthier longer if you have a lead antimony battery in a float type application, like a grid type application. Now, lead calcium batteries are typically telecom batteries, and the lead calcium batteries were developed for telecom applications to sit in float. If you have a grid tie application, a lead calcium battery is actually the better solution for it, because what that does is a lead calcium battery wants to float. It wants to sit at a high charge state over a longer period of time. Up until the last 8, 9, 10 years, lead calcium batteries were generally a bit smaller. They were 12-volt monoblocks. Recently, over the last decade or so, the battery manufacturers have come out with larger capacity calcium batteries, because some of these systems, customers don't want to do the maintenance on flooded. They want to put in a calcium or a valve regulated lead acid battery. So they're becoming more competitive with the flooded lead acid batteries. So you have those options. Okay, so just some of the checkpoints if you're doing a good and bad list. Upfront cost in general, a flooded lead acid battery, regardless of the manufacturer, is going to be the lowest cost option of all three of these. So your individual upfront cost in these systems is going to be a lot less expensive with flooded lead acid batteries, because if you spend $3,500 on a 400 amp hour flooded battery, your AGM is going to be right around $4,500, while your gels are going to be about $4,800 to $5,500 for the same size. You do pay a little bit for that. You do pay a little upfront cost for that, not that maintenance free, or that lack of doing maintenance. Overall maintenance, the AGMs and gels win. Basically, if you're only looking at them every 9 to 12 months, or every 6 to 12 months, depending on where you're doing your maintenance, the more often you pay attention to your batteries, the longer they're generally going to last, because you'll be able to detect problems or issues faster. AGMs and gels really win that market. Ease of maintenance, again, AGMs and gels, all you're doing is you're checking your voltages periodically, or you are checking your connections every once in a while. They make the AGMs and gels or valve regulated lead acid batteries make things a lot easier. Moving on, will they freeze? Gels and floodeds, definitely, they will freeze. Floodeds will freeze. Typically, a fully charged 1265 specific gravity or greater will freeze at negative 59 degrees Celsius. I'm sorry, negative 59, yeah, negative 59 degrees Celsius. But that same battery that is at 20 degrees Fahrenheit or negative 6 degrees Celsius at a 1220 specific gravity will freeze. So flooded batteries will freeze. If you're putting this on a porch or you're putting it into a basement or somewhere where you see a lot of cold temperatures, you want to be careful. You want to make sure that you put the batteries in a decent area, regardless of the type of battery. Now, the nice things about AGM batteries is that there's not a whole lot of electrolyte in those batteries, so they won't freeze as easily as a flooded or a gel battery will. So, if this battery is going to go into a cabin in Yellowknife, that customer is not going to be there for 6 months. I'm going to put an AGM battery over there versus a flooded or even a gel, just because I'm not really worried about it. If something happens to the solar array, it's probably not going to freeze to the point where it's going to blow it's going to blow out the sides. If you stick a flooded battery bank in that same spot, and it gets too cold and freezes, and the batteries or the panels get covered up, you're going to have a problem. Troubleshooting. Flooded batteries win the troubleshooting. Actually, I'll speed up a little bit. Troubleshooting and recoverability. And what I mean by troubleshooting is that when a customer calls with a problem with a valve regulated battery, you've basically got to be able to do a load test. If you're not doing a load test, if you can't look at your voltages over a period of time with current, you're going to be very hard pressed to figure out what's going on with that system. Recoverability. The nice things about flooded batteries, if you do have a customer who is abusing their batteries, say they're undercharging them or they're not maintaining them, or or even if they're overcharging them, a lot of times you can do things by doing equalization charging or going a little bit more aggressive with your charging voltages. A lot of times you can do things to recover those batteries. Unfortunately, with gels, it's very hard. You can't even do an equalization charge with gels. While you can equalize AGMs, it's not the best thing for them. But recoverability, if your customer makes a mistake with floodeds, typically you can recover it. If a customer makes too many mistakes with a gel, you're in trouble. AGMs are a little more forgiving when it comes to mistakes, undercharging or over discharging. It's something to watch out for. End user help required. Basically what this means is that you go out and you install the system. If I go out today and I install a battery bank, if it's a flooded lead acid battery bank, I've got to have help from my customer. My customer has to buy in on doing their maintenance. If they don't, if they aren't willing to do the maintenance, they're scared of doing the maintenance. If all those factors apply, then a flooded battery is probably not the best thing for them. If I have that type of customer who doesn't want to get involved, then I'm going to be looking at probably putting in an AGM or gel, a little higher cost. Gel if I need the longer lifetime. AGM if I'm looking for 5 to 8 years of life out of the batteries. Next thing, temperature sensitivity. All batteries, regardless of the chemistries, they operate the best at 25 degrees Celsius. While some batteries handle heat a little bit better than others, or some batteries handle cold temperatures a little bit better than others, all batteries are depending on the chemical reaction to happen at 25 degrees Celsius for it to happen at max efficiency. Okay. So as a battery gets hot, you lose cycle life. As a battery gets cold, you lose capacity. And so be very careful with that. There's a lot of battery manufacturers out there today that are telling you that, oh yeah, our batteries handle heat more, or there's a lot of quotes or requests for quotes or bid tenders that require batteries that will handle hotter temperatures. There's no such a thing. Unfortunately, I hate to tell you that, but all batteries want to operate at 25 degrees Celsius. The closer you can get them to 25 degrees Celsius, the longer they're going to last. Last but not least, cycle life. Flooded batteries typically are at around 14 to 32, roughly 1,400 to 3,000 cycles. Gel batteries at 50%, they're doing about 3,700 cycles. AGM batteries, 800 to 1,400 cycles, depending on how hard you work them and, of course, the temperatures. So be cautious. Make sure you understand that. So where does it all come into play? Flooded batteries. In summary, when would I use a flooded battery? Number one, when my customer, what I like to call is buy-ins, they buy in on the care and servicing the battery. They're willing to do some of the maintenance. They are willing to look at the batteries periodically and pitch in a little bit. Either that, or they're willing to pay you to come out and do some work. Flooded batteries, when the batteries are going to see, again, going back to the maintenance, when the battery bank will see regular maintenance, typically 1 to 3 months, depending on the installation, depending on the customer. Flooded batteries are also great where the end user is likely to abuse the batteries. If you have a client who is going to possibly abuse the batteries, if you put in a set of gels, you're going to have basically hunks of lead sitting around after a couple of years if they continually abuse the batteries. While a flooded battery, you're going to be able to recover. In most cases, you're going to be able to recover it a little bit better. So, AGM batteries. AGM batteries are great where a customer wants a maintenance-free battery, where you're going to see maintenance only about every 6 to 12 months, and then when you're going to see extreme cold temperatures. That's usually when I'm looking to put in an AGM battery for the customer. For example, a hunting cabin in the woods where they're only there 4 or 6 months of the year. Weekender cabins where they're there on the weekends for 6 months of the year. Systems like that, where a customer, even customers who are living off grid, who understand that they're going to have to replace the batteries, every 5 to 7 to 8 years, depending on how hard they're working those batteries, of course. Those customers are good for putting in some sort of AGM or valve regulated battery. The next, last but not least, is our gel batteries. Again, maintenance free or your low maintenance. But this is for the customer who looks at that AGM and goes, well, I'd like to have a valve regulated battery, but I'd like to get 2,000 or 3,000 cycles out of that AGM battery. In that case, then you step them up into a gel type battery that's going to give you a longer life cycle than an AGM. So, so that's it for the presentation today. Again, my contact information is, if you have any questions, feel free to send me an email or give me a call. If you want to send me probably the email is usually the best way to do it, as I am traveling quite a bit. So thank you very much for listening. Have a good day.